Okay, everybody, welcome to another session, expanding the Tidyverse. We start today with Patrick Weiss from Vienna. He will talk about tidy finance with R, and I just turn it over to Patrick.
Thank you very much, Karsten. Hello from my side. I'm really excited to be here today and to present my little project here. So what is Tidy Finance with R? What is this talk actually about? So a actually feels like a very long time ago, Tidy Finance started as a project by 3 PhD students. You see Christoph, Stefan, and myself here on this slide. And we were working on our papers, being PhD students in financial economics, and realized that around the world, repeatedly, people reinvented the wheel, or you could say as much. Many efforts in our field actually start from a very shallow point. And every individual, be it a student, a researcher, would overcome the same struggles, find out about particular areas about the specific database, identify commonly used procedures and corrections and so on. And this is at least partly a waste of time, of precious resources. Just think about the young, brilliant minds that should actually invest their time in this about financial economics, which is really important. And they have to reinvent the wheel. We were actually puzzled by the lack of transparency and reproducibility in our own field. And this extends beyond the 3 of us, where more senior figures actually also wrote about replication crises and similar issues. So in the end, we wrote Tidy Finance. But Tidy Finance is more than just our quest of 3 former PhD students from the Vienna Graduate School of Finance. Tidy Finance is actually an open source book down, which is available at tidy-finance.org. It's open source, it's freely available, and it's our contribution to stepping to reproducible finance. Tidy Finance is a fully transparent code basis for many research applications in empirical finance. They are up to date, up to par with the standards in leading journals at the moment. It is meant to be a resource accessible for students, lecturers, and professionals alike who either already use R or potentially want to use R in the future. Think about using R for a finance-related question. It is, as the name suggests, a book that is centered on the Tidyverse, on tidy principles as far as we can take them. And actually, financial economics is still evolving, right? That's true for all sciences. So Tidy Finance really probably is a never-ending story. Progress is good, but for us, progress means having to revise chapters, having to create new chapters. But we are committed to doing so and keeping it up as long as we are around. And I hope that is a reasonably long time. Now, I will cover who should read Tidy Finance. We actually have 3 core audiences in mind. This is, at the one hand, as students. These can be like undergraduate students towards the end, having a finance specialization, but also graduate students coming from programs in finance, typically. We also thought about making Tidy Finance available for a self-studying course, so being accessible for people who do not have a lecturer to assist them. Each chapter has exercises, so you can provide a good check on your own progress. And in any case, we hope that students who use Tidy Finance, discovered it at one point, will return to it when writing a thesis, another paper, progressing to professional careers to use what we provide. Similarly, we think of instructors. not as the opposite of students, but being at a university as well. We think that lecturers who teach empirical finance courses will find Tidy Finance particularly useful and can use it as a main textbook. Actually, Tidy Finance is used today as a textbook for lectures already, but it's not limited to that, given the self-contained structure of all the chapters we provide, as good as self-contained as it can be. Lecturers might also find it helpful to pick certain chapters, like a machine learning chapter, to introduce it to their audience, and therefore zoom in on particular topics as they want to have a complementary textbook. Tidy Finance is also geared towards professionals, be it data analysts, scientists, portfolio managers, things like this, who work on finance-related problems. We have a lot on financial data, and moreover, we really provide easy-to-use tools. You can adapt them to the specific need you have, but you can always have a stepping stone where you can start from. Now, all these three groups might be from a diverse background with their knowledge of R or with their knowledge of finance. And we really think about both groups. So the background knowledge is not a strict requirement. The R crowd will find our applications of financial problems useful. The theory we provide, the tools commonly used in the field, will really benefit an R efficient user. On the other end of the spectrum, you can think of a finance person, whoever that might be, and they will find it very helpful to have implementations for empirical analyses they have to do. Use Tidy principles to augment their finance background. So really think about a broad set of people, a large audience coming from diverse backgrounds. And it was our goal that Tidy Finance is a resource for all of them. Now, more specifically, what is actually covered in Tidy Finance? We cover a variety of topics. In our introduction, we try to pick up on what an undergraduate student would be doing. Certainly, I did it. We show how our Tidy Finance approach works, how we want to use it. And this is, in fact, something I really did in an undergraduate course. Download data from Yahoo Finance, formulate a portfolio choice problem, and compute an efficient frontier. These are all finance concepts, and we show the Tidy way of doing it. Then, and I think this is a really important contribution of Tidy Finance, we work on financial data. We show Tidy data, of course. We show how to access Farmer French data, how to access macroeconomic data, but also how to access the Wharton Research Data Service remotely, which is really important because nowadays many students and researchers alike use WRDS regularly to, for example, download CRISP and Compustat. And there's a really nice way of doing this within R, and we actually show that. And then database management as well. Then coming to the more applied finance topics, we cover asset pricing, beta estimation, but also portfolio sorts, and something that has been appreciated by many people. We provide a replication of the Farmer French three factors, which is really something that a lot of master students have to do at some point, which is really something a lot of people do over and over again. The same being said for Farmer-Macbeth regressions. Tidy Finance got you covered. More recent development, or like more on the trends of the field at the moment, we introduced machine learning to finance. We look at factor selection and option pricing here, cover topics from bridge to lasso to neural networks and things like this. Tidy Finance, of course, has to use Tidy models as well, a great tool. And then where we have to, we step beyond but go for carrots. Then finally, also probably very applicable for a lot of professionals. We discuss portfolio optimization in R. We show parametric and constraint portfolio optimization, but then importantly, we also cover performance evaluation and backtesting. And that's not it. Actually, there's more in the book as we speak, but we're really open for suggestions and we really look for your feedback here. So if there's something missing from your perspective, let us know. We would love to have your feedback on this. So why R and why Tidyverse, given that I'm presenting at Use R in a session called Expanding the Tidyverse, these things might be redundant and you already have a good feeling, but R is really among the best choices that you can use for finance programming. And there might be people out there who dispute this claim, but we really think that this is the case. The community is just amazing. We have packages that cover a lot of ground that are also very needed for finance applications. If you're worried about speed or things like this, the integration of other programming languages is very smooth, and well, our studio deserves love by everybody, I would assume. And Tidyverse, I mean, we don't have to discuss about this, and I think there's not a lot of dispute here. Is the way for data analysis. Tidy data cause joy, and the consistency across packages in this family is really just outstanding. Yeah, and with this, let me give some final remarks. I have actually good news to share, which we have not shared as far as we are aware. Tidy Finance will be published as a textbook, giving us new energy to invest into the project. We signed a contract with CRC, and we will publish in the R series. We hope that this happens somewhere next year. Importantly, however, we stipulated in the contract that Tidy Finance org will remain a free resource. This is a condition that we would not sacrifice on. We think that this is the main goal. You need to have online, publicly available, free resources to make an impact here. So this is what we do. We can update it. We can adapt to new streams in the field. This is ensured. And with that, visit the homepage. Thank you very much. And I have the email address here, but you can as well just contact us on our socials, and very grateful for your feedback.
Thank you, Patrick. That was a very interesting talk, and I think it shows where education inside universities or outside universities actually goes. Books become interactive and way more open for self-learning than a book was before. Please, for the attendees, go to the question and answers sections and post your questions. And I have one here already from Janet. Are there going to be integrations with the QuantMod package as well?
Our goal is to be as much independent of non-core Tidyverse packages, I would say, as we can. But where necessary, I think we already rely on it. I'm pretty sure we actually pushed it already in the current version. So yes, absolutely, we will use whatever is out there to drive financial applications in R, but our prime goal would be to do it in a tidy fashion that is very accessible for the crowd.
Okay, please type in your questions. I have a question. I use the chance here. It's a more technical question. How did you implement the exercises? Did you use Learn R? And if so, are the exercises available offline in a local server or on a Shiny server, or how did you solve that problem?
So at the moment, the exercises that we have created are what you would expect from a more textbook style, like exercise X, Y, and do X, Y, and Z. But of course, as all of these require implementation, we thought about pushing an entire GitHub repo just dedicated to exercises concerning tidy finance. Yeah, I have not thought about extending it to learning R or similar ventures, but I'm sure to explore this opportunity.
Just a follow-up question. You used Bookmark for tidy finance, is that correct?
Bookdown, yeah.
That's the standard version from RStudio, right?
Yes.
Yeah, I'm drilling a little bit because I'm writing currently a machine learning book, and so I'm interested in every new technology solution that can make it more accessible for people who read it.
Yeah, so the Bookdown was fantastic. Works really well, and I would not, also the integration with not exaggerating too much, but with CRC is also quite nice.
Sounds good. Any more questions from the audience? Please go to the question and answer sessions. Okay, then thank you very much again for the interesting talk. And we move from Vienna to Australia, from Austria to Australia. Dax Kelly will tell us about exploring biodiversity databases is tidier than ever. And I think that's probably not only interesting for biodiversity databases. I think somebody who, like me, who works with other databases probably can learn a lot from your talk too. Dax is an evolutionary biologist and data analyst at the Atlas of Living in Australia. So Dax, please go ahead. Just share your screen.
All right. Thank you for the introduction, and I'm very excited to speak here today. I guess the main part of my talk is going to be speaking about a package that we've made, and I guess we'll get right to it. All right. Biodiversity data is growing rapidly in large biodiversity databases. The Global Biodiversity Information Facility, or GBIF, currently holds over 2.1 billion records of species observations globally. And as you might imagine, this amount of data can be very useful for understanding ecosystems and to monitor terrestrial and marine life. These data can also enable researchers to test big data hypotheses about species distributions and interactions. A lot of this data growth has happened over the last 10 or 15 years. In GBIF's case, record numbers have grown by over 1,600% since 2007, when they held 125 million records. To put that in context, if a human grew in height by that amount, they'd be taller than 2 of the Hollywood signs stacked on top of each other. It's a bit weird to think about, but that's what it would be. GBIF aggregates data globally from a series of partner node organizations, usually for individual countries who are responsible for aggregating data from providers in their nation or region. For example, there are biodiversity databases for Tanzania, Spain, Sweden, and Australia, just to name a few. And as of a few months ago, there's even a new website where you can see all the living atlases hosted by GBIF. Now, I work at the Atlas of Living Australia, or the ALA, which, like other databases, consolidates data from museums and collections, government organizations, research groups, monitoring programs, and citizen science apps like iNaturalist and eBird. Some of you might even use these apps yourself. Nodes like the ALA are important for maintaining data sharing arrangements among all of these groups, and they can provide more specific data or data services. So, for example, providing specific state or regional threatened species lists. And so it can be valuable to search for biodiversity through specific nodes, not only on GBIF. R is a popular interface for ecologists and biologists who want to statistically analyze species observations data. And R is particularly useful because it is possible to make the entire process of analysis, from first downloading the data to the final results, transparent and reproducible. This is an essential part of good science practices. A few packages have made huge strides to make this possible, but with the growing popularity of the Tidyverse among R users, especially new R users, these packages, useful as they are, may not be the easiest to first jump into using. Two popular packages for working with and downloading biodiversity data are the TaxSize package for searching taxonomic information and the RGBIF package for downloading data from GBIF. Both of these packages are made by Scott Chamberlain and rOpenSci, and they are awesome, but they are not the easiest packages for a beginner to pick up. For example, the output of TaxSize provides a list of attributes, which probably looks pretty intimidating for a beginning R user used to Tidyverse syntax. And you can use TaxSize with RGBIF as one way to filter a data download query, which is composed of these pred or predicate functions that specify one filter each. And although this can work really well, it can get pretty unwieldy pretty quickly. And again, a beginner user might find this intimidating or unintuitive. Now, I just want to reiterate that these packages are great, but they highlight how working with APIs or programming interfaces that return results from a query can be a nightmare, and translating them into R syntax isn't easy. Our own original R package for the ALA, which was called ALA for R, struggled with the same issues, and most of its syntax was just jumbled and inconsistent, and it catered to the API, but not the R user. And so we built the Gala package to query data from the ALA, named for that beautiful Australian bird in our hex. Gala improves on previous R packages in two ways. Gala queries a national biodiversity database, which at the time, it was the first one to do so. And it is flexible enough to even work with other national databases, which I'll come back to at the end. And somewhat accidentally, we realized that filtering a query works a lot like filtering a data set, and the Gala package builds queries in a tidy and pipeable way. So to start, let's build a query with the Gala package just to see how it works. Let's download the number of Gala records in the ALA. This basic query demonstrates the major components of how the Gala package works. You start with a query with the Gala call, which effectively works like a simple .data argument in dplyr. Functionally, it accepts subsequent Gala functions as filters. And here we identify our taxonomic group to be the genus and species name for Galas. We end our query with an atlas function, and it ends the query itself because it specifies the type of data we want to returned, in this case, record counts. And when run, a tibble is returned with the total number of records, about 991,000. Now here are other Gala functions to help narrow query results, and Tidyverse users will notice they have the same names as filter, group by, and select in dplyr, and that's because they essentially do the same thing to your query that you would otherwise do to your data set. Gala filter filters rows, and for our query, this means that we can filter to only return the number of Gala records since 2010 recorded through iNaturalist. What would normally be columns to filter your data in dplyr are fields that you can filter searches by on the website. But they're effectively the same thing as columns anyway. And the Gala package has a few helper functions to help search for these fields. We can group our counts by using Gala group by. Here we group by year, and the output looks like something we might get by running group by and then count functions with dplyr. And we can even group by multiple fields, in this case by year and by the data source. We can also get a list of species. In this case, I want to find all the bandicoot and bilby species found in 2021 in New South Wales. And if you don't know what a bandicoot is, there's a picture for you, and they're pretty much a really adorable, mostly nocturnal marsupial, and they're really great. By calling atlas species at the end of the query, we return a list of the 3 species found. Now, we might want to download species occurrence records to analyze the data ourselves. And to do this, we first have to supply a registered email with the ALA, which is a requirement of our database, even on the website. And then we call atlas occurrences at the end of our query. And we get a tibble of 2,156 records with their location, scientific name, date observed, and the specific record ID from the ALA. But sometimes you might not want all that information because getting all the default columns can increase the size of a download. I've experienced this problem myself. So by calling Gala select, it selects columns. And here I select only the scientific name and the event date to be returned. Now, when combined with other great packages like OzMaps, like the OzMaps package and the SF package for plotting spatial features and ggplot2, going from downloading data to making something nice like a map of observations can be quick and transparent. So for example, if I wanted to map the species records of bandicoots and bilbies, I can download my data with a few filters, fix up the map projection to what the ALA uses, and plot the points with the supplied lat-long coordinates. And thanks to ggplot being awesome, this looks pretty nice already. Now, over the past decade, the ALA implemented a program to set up other living Atlas nodes to use the ALA's API architecture, with the goal to make their systems more cohesive. And this means that information is stored in similar places, uses similar fields, and returns data in similar formats. And thanks to this massive effort, this was before my time, we just needed to point the Gala package to use the URL of one of these living Atlas APIs, and it can begin to return data. So for example, if you set the Atlas argument in Gala config to Spain, you can return the total counts for the Spanish Atlas. And you can do the same thing with the Austrian Atlas. So you can try that out, Patrick. And there's also a few others. At the moment, this only works with atlases that use ALA's architecture. Other atlases work just a little differently. And we're currently experimenting with how much work it would take to make Gala use their APIs correctly. But there's a lot of potential here, and this could be really exciting. We have already been contacted by a few atlases about the potential to support or make an R package for their atlas. Now, although making data easier to access in R is a good first step, biodiversity data is only truly useful when it is applied well and transparently. So to help do this, we made a beautiful Gala-themed package down website with brief articles and examples of how to get started. We also made the ALA Labs website, designed as a resource for people who are interested in more technical code-based ways to make data visualizations and run statistical analyses in R. Now, the website's main focus is to share how-to posts about how to use Gala to make or do cool things, and I really encourage you to check it out. We made Gala to make downloading biodiversity data from the ALA easier, and what I've shown isn't even everything it can do either. But inspired by the Tidyverse, Gala makes downloading data like wrangling data with dplyr, which helps people who have used the Tidyverse jump in quickly. And the architecture of Gala is flexible for APIs of other atlases, and we're currently trying to see how it can help with other biodiversity databases too. With these innovations and with the help of ALA Labs, we hope that the Gala package will make it easier for people to access and analyze biodiversity data reproducibly. Thanks.
Thank you, Dex. I see we have already questions here. And I start here with Jesse. Is the website / documentation available in multiple languages?
Could you say that one more time, please?
Is the website and documentation available in multiple languages?
Ooh, not at the moment. I used Quarto for this presentation, which really showed me that there's a lot of possibility there. We also have a number of Python users, and we're looking into make that available. But I think it was already so difficult to get this to work in R because we already stuffed up the first try. So, you know, baby steps. But yeah, definitely looking towards making it available for more languages.
Well, we have quite a good audience here. So maybe somebody who's native in this or that language can help with the translation.
Yeah, absolutely. Please actually reach out if you feel like doing that. I think we would be really interested because GBIF has made a lot of people realize that having a global space for this is important. But we've been speaking to people in Brazil about getting this working, and it's valuable to be able to have this kind of stuff available internationally.
I have another question here from Janice. Does Gala identify, so the command, does Gala identify accept shortened names such as N. Like Alexis D. Blucy? Sorry for slaughtering the terminology here.
That is a good question. I think if I recall correctly, I think you can look for species and it might return something, but it's better if you do genus and species full name, because we do kind of a fuzzy text match way of matching names, and it matches directly to the website. So I don't think that search returns what you want on the website, and so probably won't do the same thing for Gala either.
Okay, I have a couple of questions actually, but this one is, can you say talk a little bit about what Living Atlas is? I heard about it, but I think many of us probably don't know what it is. Is it a database?
Yeah, yeah, exactly. That is what it is. It's funny. A lot of people don't know that they exist, but read things, articles, releases from their respective governments about in the environment in their countries. This is probably where all that data is coming from. But yeah, probably most importantly, it combines monitoring programs that governments might have, along with citizen science programs like apps that you use, regular people taking photos of birds and stuff, as well as research programs from universities. All of that stuff is aggregated together in this huge database, which takes a lot of time to make it work. Like I said, GBIF has over 2 billion records, and that's just reflecting what's in all these other smaller atlases. But it's really just a mega space for data. It's pretty impressive.
I know Living Atlas from a GIS perspective. Is that what it is, or is that a different Living Atlas?
I think that's probably how a lot of people know Living Atlases, and we're starting to try to move towards new ways of accessing it, because that's not for everybody, but yeah.
Another question is, we heard about financial data. I was thinking, okay, I think your tool is great for dealing with databases. The syntax is so close to Tidyverse, so it's easy to use. As an economist, I was asking myself, can I work with a financial database? Can I tweak it that it does work with a financial database? And if so, what are the requirements from the database that it can work?
Sorry, I missed that one. Is that for me?
Yeah, that was for you.
Oh, there you go. I thought we were going back to economists.
No. Sorry. Can you tweak Gala to financial databases?
If I'm honest, probably not. And I think the reason is because it depends on an API that we've had to work to translate. I think maybe if you did a lot of work with an API, you could start doing that. I think what we've realized is that if you're working with an API, creating something that creates like a fake data argument can mean that you can work with things before you actually download it. So maybe if there's some sort of data that you get through an API for finance, that would be useful. But I don't know how easy it would be. We'd have to have a lot of time possibly working together, trying to figure out the best way.
Okay, Patrick, that's some open collaboration for you.
I guess there is already a lot out there. So a lot of the common APIs have been already ported into R.
Okay, we can almost move to the next talk, but because we have a minute left, just an almost unrelated question. I saw you highlighted like a single line in your code in your presentation. What did you use for the presentation? I thought, which tool?
I used Quarto to make this one, and
okay.
Yeah, I would recommend it. I mean, it took a little bit of work to get used to it, but it does make things look nice, even though I definitely didn't do the hard work there.
Okay, sounds good. Okay, So you use Quarto has its own presentation tool, so you don't have to use Slidey or something like that.
I think, yeah, Quarto, it works a lot like what exists in R, like Zeringen, but it tries to be without a language, and it looks a lot like an R Markdown and works a lot like an R Markdown document, but there's just a few CSS quirks in it. But the baseline thing looks great. That's pretty much what I use for most of it.
Okay, thank you. Okay, we move from Australia to Florida. Thanks again to Dex. It's in the middle of the night or early morning, 2 o'clock by now, I guess. So we go to Corey, and he talks about toward a tidy package ecosystem for topological data analysis. And I asked for a short introduction. So he wrote, I'm a mathematician by training, data scientist by tuning, outcomes researcher by testing. So that's an interesting way. And I think because data science is so young, I think many people go very indirect ways to become data scientists. And I'm looking forward to your talk, Corey. Just share your screen.
Thanks, Karsten. I just shared in the chat a link to a gist where the walkthrough I'll go through next is located. But first, I want to take us through a little slideshow, as others have, to outline what we're after. My two co-organizers and I have been working on and off on this very much still work in progress for a couple of years. We'll keep at it for a couple of years more, I'm sure. But I think it's grown enough that we're really interested in getting feedback and contributions from the user community. So this is my opportunity to put in that plug. The photo here is from my new location at the University of Florida. I've actually never been to a university football game, but what the marching band is doing here, a set of discrete units evoking a continuous pattern, is very much what topological data analysis is all about. So I thought it was appropriate. In addition to many other helpful people, I want to spotlight Yara Scaff, who's an MD PhD student who's done a lot of work with me on this software package, as well as many other things during her career. So I feel I need to introduce topological data analysis, and I'll do so by way of the two most common techniques. The first is called mapper. Both these techniques begin with a point cloud, that is to say, a set of data with some sort of distance measure between individual points. The mapper construction begins by projecting what typically is high dimensional data to a lower dimensional space, using a cover, which is to say a fuzzy cluster on that low dimensional space, and then pulling back those cover sets to the high dimensional space in order to do clustering, which saves a lot of computational cost. Once those clusters are constructed, their overlaps allow you to create what's called nerve from the cover. And that nerve is a simplicial complex, in this case a graph, that captures the topological properties, or some of the topological properties of the original space, in this case a loop or one-dimensional feature. The other most common methodology is a little more strict. It's called persistent homology, so it's less flexible in that sense. It also begins with a point cloud, and here we have a tower of ball covers centered at the individual data points, which are similarly converted into a filtration of nerves, it's called. That filtration can be handled very elegantly in an algebraic fashion to produce topological features, which are usually summarized as persistence data and visualized using a barcode, a persistence diagram, or something else. So I want to make a little bit of a case for the use of TDA in more general scientific applications. One is from my co-organizer, Raul, who with his team took a series of black and white tumor CT scans, binarized them, or grayscale CT scans, binarized them into black and white at different grayscale thresholds, and used that to construct a persistent homology. Based on the persistent features they observed at each dimension, they calculated the moment within each dimension and used those 3 or 4 moments as continuous valued predictors in a survival model, which it turns out were able to distinguish better or worse outcomes among their patient population. A different kind of approach to using persistence data in applications is as a pre-processing step for machine learning purposes. Machine learning requires, or many applications require, something called backpropagation, which means that your output vectorization of your data needs to vary continuously with the input data. This is famously not the case with raw persistence data, but it becomes the case after taking that persistence data and processing it into what this team calls a persistent image. A third application uses the map reconstruction. So these researchers were looking at aortic stenosis patients using a variety of echocardiographic measurements to summarize them. These measurements produced a fairly high value data set, which through multidimensional scaling, they projected down to a low dimensional space, and then went through that map reconstruction I described earlier to get this, again, one-dimensional simplicial complex, or a network, which they annotated according to the severity of the disease represented in each patient. And so what they're able to observe here is that there are two distinct pathways from mild disease to more severe disease, which correspond to different phenotypes of moderate disease. So there exists a variety of TDE resources already available to our users. Some of them Python modules and packages that can be ported through Articulate. I won't go through them all, but I want to point out there's a couple. They fall into, as we believe, a couple of bins that leave an opening for a new set of software. One is that they tend to be directed either at specialists, that is to say mathematicians or programmers, whereas what we think now that several TDA workflows have become standardized and validated would be useful to be accessible just to data analysts. In terms of functionality, they also tend to be either comprehensive, all sorts of features going into one package or library, or fairly narrow, a package doing one thing and not really interfacing well with other packages. And so what we think is needed is a collection of packages that can be coupled together as needed, where each package just does one thing well. We're borrowing our design principles from the Tidyverse of accessibility towards a variety of users, opinionation with respect to good practice, and extensibility with respect to development and usability. We're taking a little more of the verse part of Tidyverse than the tidy part, because a lot of these packages just work with different kinds of objects than rectangular data, but we want to try to integrate them with that larger collection as well as possible. So the packages we have available right now are a few. They are hopefully growing. We have several more in mind. But of course, this has been a labor of love and not of pay for all of us the whole time. And so in that sense, we welcome similar labor from the community as y'all find interest. The couplings outlined here are ones that I'll go through in the walkthrough. And this slide, I've included slides in the documents, but this is just to point up that there are several low, moderate, and high hanging fruit available to those interested. So I'm going to jump now to an RStudio session where I want to illustrate just some of the functionality that the collection provides. First off, this is to help anybody who's using this for the first time to have every package installed that they need. This is installing a specific older version, the upgraded version of Simplex Tree. The reason for that I'll mention later. And the goal here is to get a little bit of a handle on what's called a Klein surface or a Klein bottle, a common object of interest in topological or in any topological area of research. I've drawn the classic illustration of one on the chalkboard behind me, but we're going to try to get a computational handle on it. It's not going to be perfect, but it's going to illustrate the sort of benefits and limitations of these tools. We begin using the Simplex Tree library or package to create a sort of template Simplex Tree and then populate it with a collection of two-dimensional simplices, which provide a vertex minimal immersion of the Klein surface in 3 dimensions. We can just inspect the object to see that it's a Simplex Tree with 0, 1, and 2-dimensional simplices. I'm going to verify that this is actually a triangulation of a two-dimensional surface with no outlying extra simplices. And then we can get a visual on that as in the top right panel. This is not the most elegant visualization possible, but it's a way that keeps simplex tree minimal and lightweight. And this visualization technique is based on, I mean, it's called phylotactic spiral, but the way a lot of biological processes, flower petals and seeds and so forth, work their way out in a way that is most exposed to the viewer. So it's a good deterministic layout choice for this purposes. So that's not entirely helpful. We'll see if we can at least get calculate the Betty numbers, that is to say the dimensions of homology groups in 0, 1, and 2 dimensions of this simplicial complex. And I'm sorry for all the terminology, but those who are familiar with topology will love this part, I hope. For this, we don't have that kind of functionality implemented in simplex tree. And so what we're going to do is use the interplex library to convert this to a Python GUI simplex tree. For calculating Betty numbers, there's a little bit of a bug where I'm just adding a kind of blister onto this simplicial complex. It's not going to affect the numbers, but it's going to produce the second dimensional homology. And I can compute the Betty numbers in this way. And this will be recognizable as the Betty numbers for when you're using integer valued coefficients for your homology. So that's discrete topology. I'm going to jump again now to more statistical topology. And to begin with, use the TDF package to generate a uniform sample from the surface of an embedded Klein bottle in 4 dimensions. There are 2 famous embeddings. I'm going to use the so-called flat embedding to begin with. We can get a little bit of a visual on what this is by looking at pairwise coordinate projections. But then we're going to see if calculating persistent homology on this point cloud is able to recover what we know to be the underlying homology of in particular, one-dimensional feature. For that, I'm going to attach the RipserR package, which is just an R interface to the Ripser and cubical Ripser persistent homology engines. We plug the point cloud into the Viator's Rips function and get this set of persistence data, which is contained as a phom object. But a phom object under the hood is just a data frame, and so we can plug it through this sort of dplyr-esque pipeline to look at the 1- and 2-dimensional features of highest persistence. Now, again, these are easier to understand visually than numerically. So for that, we attach a ggplot2 extension called ggtda, which helps us produce, in this case, a barcode of these persistence data. And what we can see, at least hinted at in these data, it's a small sample, is that we have one standout one-dimensional persistent feature, which is consistent with our simplicial homology calculated earlier. A question that's often asked in analysis of real-world data is whether persistence data obtained from one sample agrees with persistence data obtained from another sample. For that, we can attach the TDA stats package, which provides some of these kinds of tests. So as an illustration, I'm going to sample a similar number of points from a different embedding of the Klein surface in 4 dimensions, called the tube embedding. I can get its barcode using the similar pipeline, and we notice a little bit of differences. And so the question is, are those differences really statistically detectable? So this is a null hypothesis test that is performed using the TDA stats package. I'm using a little bit of dplyr magic to inspect those results. We see that there's a very significant p-value with respect to 0-dimensional features, but not really one for the 1-dimensional features. And if we visualize, this is a simulated-based p-value. So if we look at the simulated distances after permutation-based resampling with 0-dimensional versus 1-dimensional features, we can see why one of those is significant and the other one is not. How am I doing on time? Do I have 1 more minute? I'm assuming I do. What's going on?
Yeah, you have it. Sorry, you have about 1 more minute, but that's pretty much what is left over. Sorry, I had to find my mute button.
Okay, no worries, thanks. So what I'm doing here is installing an older version of Simplex Tree. This is due to a problem that arose while we were upgrading both Simplex Tree and Mapper, which introduced an incompatibility that's not yet resolved. And so if we're using Mapper, we have to install this older version of Simplex Tree. With that, one more approach to inspecting this point cloud is to try a Mapper construction on it and see if we can get a better maybe visual of what a client surface might look like. I'm using a larger sample here because Mapper is a less robust construction. Here, I'm just constructing the Mapper using a handful of conventional choices. I construct the simplex tree, the simplicial complex from them. And then one thing I can do is directly inspect the cover sets and their pullbacks. But finally, to get that visual, I'm going to annotate it by color coding according to the lens function that we used, and then visualize that simplicial complex using this layout as I think borrowed from iGraph, which provides us with at least the indication that there is a one-dimensional feature in this point cloud that we are able to detect using Mapper. The code is, again, on the GitHub gist if anyone would like to use it for themselves.
Okay, thank you so much, Corey. I think the talk showed, at least to me as an economist, economists tend to look up to mathematicians. And now I know even more why I'm looking up to mathematicians. It's really cool what you can do with mathematics. And I think this was always for a long time covered, but with data science, that becomes obvious. I see a question here. I think we have time for one question here. Do you have good instructions tutorials about TDA for more classical data scientists?
Raul has been really insistent on us writing one. There are a handful that I can recommend. I don't have them on hand, but feel free to contact me. I can send you some pointers. But yeah, it's something that we are interested in doing. I've been resistant to do it until the package collection is more feature complete. But what Patrick showcased earlier, it would be a long-term goal of once this package collection is more stable.
Sounds good. Thank you so much. I see there are no more questions. We are perfectly in time, so we can move to the last talk from Brian Shalloway. He's a data scientist at NetApp, and he will talk about 5 ways to do tidy pairwise operation. Brian, it's all yours.
Thank you. So I initially wanted to go through 5 different ways. I ended up trimming that to just 3. Even then, I think at points it's a little bit of a whirlwind, and my goal was more to just give kind of the smallest little taste of each example. So you can go look up the functions later, and I'll have references at the end, and I'll be uploading the slides to GitHub. Also, it was really cool going last. All of these other presentations were so cool. I feel like my contributions on my project are so modest in comparison, so it's really cool seeing all the projects you guys have worked on. So happy I got to watch all of those. And the actual parts that I cut from the presentation were all the things that I had actually done kind of in this space. So I'm mostly presenting on other people's stuff. So the motivation for this talk came largely by me just on multiple occasions needing to do some kind of non-standard thing with a bunch of pairwise combinations of columns, and finding that each time I did it in some little different way. And eventually I just started documenting my examples of different ways I had done this, like just keeping a log of like, I would try and do like a tweet each time I did some different way of doing pairwise operations, and then just save that at the bottom of a blog post. That was kind of the start of it. And then ended up writing a package that would for doing pairwise operations in a way that was really consistent with the dplyr cross function. And then I ended up seeing this other package, dplyover, that essentially had that functionality and a lot of other stuff. So that's what I'll be mostly advocating for people to look into. And that's kind of what I'll build up to. In the meantime, though, I think there's a few really useful functions for if you're doing pairwise operations. There's a few really useful functions in other Tidyverse packages that might go undiscovered. So I just wanted to kind of call those out as, oh, here's, a few other places you might look as well. And these will be those links. So these are the things that I worked on, but these are, again, cut from the talk. And the data set that I'm going to be using for this is the Palmer Penguins data set. Note that I've just renamed some of my columns so that they can better fit on the screen. For my examples, I'll almost exclusively be using the columns with _mm in the suffix. So that is bill length, bill depth, and flipper length, all in millimeters. But I'm just using these to showcase the code examples. So I'm not actually going to be doing any real analysis here. It's more just, here's an example of the code, and this is the data set I'll be using. And then I'll also be loading, before each example, just pretend that this whole, all these packages have been loaded and this minor set of cleaning, of pre-processing the data has been done. Okay, so when I talk about pairwise operations, I mean any operation that you apply to all pairs of a set of vectors. I think that probably maybe the most famous or classic example of a pairwise function that comes to mind is the core function in R. You give it a data frame, which is just a list of vectors of equal length, and it returns the correlation between each of the pairs. In this case, I'm just selecting 3 columns to pass into the core function. For each of my examples, I'll just mostly be sticking to these, but you can think of this as being potentially a much larger set of columns that you'd be passing in. So there'll be, when you're talking about passing in arbitrary functions across pairwise correlation, pairwise column combinations, there'll be, I think at a little larger scale than I'm actually showing here. So first package I think that's important to be aware of is just the core package. This essentially gives a tidy wrapper to a bunch of base R's correlation functions. The foundational function here is correlate. And rather than returning a matrix the way that base R's core does, it returns a data frame, which makes some data manipulation do on top of that a little bit easier, potentially, or at least more tidy friendly. It's got some really nice features for honing in on your data and setting up visualizations. Not shown here, but it also allows you to run correlations on data in a database, which I think is a really, really nice feature. The function though that I'm kind of most interested for the purposes of my talk is this function called call pair map. I'm going to show the next slide that just shows a brief example of this on those 3 columns data. I'm going to give you 10 seconds just to look at it and see if you can figure out how this function works. So I'll walk through it now. Hopefully a second to kind of look through how you think this maybe works. And the name is kind of suggested in, the function is kind of suggested in the name itself, call pair map. What you do is it simply takes, you simply need to give it a function that takes in 2 vector inputs, and then it outputs a single value for each of your pairs. In this example, I modified the core.test function, which tests whether a correlation is statistically significant, and created the core p-value.
Oops. Brian, I don't know if only I have the problem. You're breaking away. Can everybody?
And R.
Oh, got it.
Oh, sorry. Did I cut out the last few seconds?
You cut out the last few seconds, but you're back.
Okay. So essentially, what you can see is happening here is that it's took in as vectors, took in each of those pairs of vectors, and then it's returning the p-value of the correlation between each of those for each of these pairs. So that's how this function is working. I think this is a nice, I think somewhat unknown function within arbitrary pairwise operations using this package. And just to kind of hammer home the point that it can be any arbitrary function that follows this rule of takes two vectors in and returns a single value. This is just another with a function that doesn't have anything to do with correlation at all, and this also runs. So you can kind of hijack this and do any kind of pairwise aggregation operation you might want to do, whether it's a correlation or some other thing that you're some other kind of aggregation you want to do. And I think without call pair map, you might end up using something like Basar's com in function or some other approach. But I think this gives a nice little, almost easier to enter wrapper for rather than having to figure out how to set these columns up yourself. So the examples I just went through have been examples of pairwise summarizing functions. And when I say summarizing, I'm saying that because each pair of vectors you're putting in, you're getting out a single value. There are also cases you may want to do pairwise mutating operations. So for example, say you think the ratios of a collection of features may be useful as inputs to a machine learning model. In this case, the recipes package, also in the Tidy Models framework, has some useful functions that can facilitate building these features that can be set up in this way. So specifically, there's the step interact and step ratio functions in the recipes package that can be useful for these kind of like mutating pairwise operations. I'm going to go through an example with step ratio. But first, again, I'm going to put the code up on the screen and give you about 10 seconds or so to see if you can follow what's going on. Oh, and just one note, notice that I use glance at the end step, which returns output in a different format than in my previous examples and in my future examples. So try not to let that throw you off. But I'll give you your few seconds again. Okay, so to walk through this, I'm setting up a recipe here. So I'm saying, you could think of this as I'm saying, I want to predict body mass in grams based off of build length, build depth, and flipper length. And this is all coming from the Penguins data set again. And then I'm doing the step ratio function. And here I'm saying, okay, I'm going to have all of my predictors are going to show up in the numerator. And then I'm also going to have all my predictors show up in the denominator. And then the step itself figures out that, okay, we're going to set up in all pairwise combinations between these. And notice that because step ratio isn't associative, beforehand we just had 3 correlations because in that case it didn't matter the order, so it wasn't showing the duplicates. But in this case, it's different whether you have build depth in the numerator denominator. So that's why we have 6 features being created here instead. And just to walk through one example, let's look at this build depth mm divided by build length mm. You can see that this is, okay, build depth mm is 39. Oh, build depth mm, here we go, is 19 divided by 39. That gives us this 0.5. So you can just see it's creating this ratio, and it's doing this across all combinations. So in this example, I'm using this, I talked about it as if we were doing some kind of like machine learning problem and actually trying to break this. But let's say you just want to create a bunch of pairwise ratios for some other reason. You could still hijack this and you don't actually need to end up building a model after the fact. So I think this is one other kind of hidden functions that can be helpful for if you want to do a pairwise operation like this, is hijacking these functions out of recipes. But these packages do have some limitations. I'm a really big fan of the core package and recipes packages, like a huge fan of both of those, but they weren't really designed with the intention of using them for doing arbitrary pairwise operations. And this is where Tim Tiefenbach's package, deep plyover, comes in. Tim essentially created a bunch of functions that are set up the same way as dplyers across, but handle all kinds of really thorny iteration problems you might run into. I'm honestly kind of surprised this package hasn't blown up yet as like a really popular dplyr extension, because it has some really cool functionality. What I'm going to go over is just like the tiniest shred of it. But I'd say really the only limitation with it is that it can be slow with big data sets or computationally intensive operations, which you can definitely run into with pairwise operations. I'll also kind of just pause to say that for pairwise operations, this package and also the map approach I showed beforehand, these are going to be doing these kinds of operations iteratively. So you can speed them up some by parallelizing, but it's not going to be nearly as efficient as like running the core function or running something that's doing that in the background that has these, that's actually like doing proper matrix algebra to do these. So keep that in the back of your mind. If you're doing things that are relatively computationally intensive, these probably isn't going to be the way to go. It's more when you have, you've got some interactive thing you're evaluating or something that's not on a huge scale. That's, I think, when these kind of like arbitrary tidyverse style approaches will actually work okay. But always kind of have that in the back of your mind, like how big is this problem I'm working on? Because they're definitely not going to be, this is not going to be like computationally optimized. And one note too is that Tim's also done a bunch of other really cool projects related to iteration. He just put out a new package recently that converts the functions from per into for loops. So let's say you feel pretty comfortable with for loops, but you still haven't gotten your mind quite around map. This, I think, can be a helpful way to kind of segue into understanding, that bridge a little bit better. So I definitely recommend checking out dplyOver, but also some of his other work. Okay, so the key function in this example is across 2x. I'm going to pause again and let you guys give you about 10 seconds, see if you can figure out how this function is set up. Okay, so what's going on here is that specifying the .x calls and .y calls here sets up the grid of variables to pair up. So by setting them both to be the same, I'm setting across 2x to map the function in a pairwise way. So that's what, this is essentially just saying, forcing across 2x to set up all the pairwise combinations. Notice also under .com, this is for like how it's being combined. I'm saying minimal, and that's because I know that this function is associative, so this is going to basically get rid of all those duplicates that don't matter. So it's going to save some computation time by saying not to run those. Again, and okay. So again, so that's like paying attention. It has a few different combination methods you can use, but that's the one. This is going to save some time in this case. And then this .funds, this is where I'm actually passing in the function that I want to map through all these pairs. Here I'm passing in this core p-value, which I showed before, and I'm just pulling out the p-value from this core.test function. So it's just testing the statistical significance, again, of these correlations. And notice that rather than having it outputted like in a matrix or in a table format, it's just you have the outputs individual columns that are paired up. So you can see, okay, here's bill length paired with bill depth. Here's the statistical significance of that correlation. But I want to call out a few things that I really like about this setup is that just notice that it works just like the way the dplyr that across is set up. This is set up in that exact same way. It also supports tidy selection directly same way that across does. So when you're selecting these variables, you can use anything you could use with regular tidy selection. And it allows any arbitrary function here. And there's different multiple combination methods you can use. So this next example I'm going to do is going to be really similar, but it's going to add a few other nice features, I think, that go with this package. So take a few seconds and see if you can recognize the differences here and how this is set up. And then I'll call out the new features.
I just use the second of silence here to give you a 1 minute warning.
Thank you. I'm almost done. So what's really nice, again, it's set up just the same way across is, so it respects grouping. So I have this group by statement here. So now rather than just having, global correlations, I'm calculating these group level, or these, in this case, these group level statistical significance of each of these correlations. So it's no longer global. Now it's, the statistical significance of the correlation specific to each of these groups, in this case, species. Also, you can put in other calculations the same way you would be able to generally. So we have this, I added this column N for the, size of each of these species, the number of samples in each one. Also, just like with across, you can pass in name lists of functions. In this case, so I changed I passed in this p-val, which is now in the name of each of my columns. And also, it's you can use lambda functions here as well, just like you can in across. So I'm kind of just with this, I'm just trying to prove to you that this works just like across. And this package has a bunch of other functions that also work like across. And I think have this like really, really nice setup that feels really intuitive. And what then I think the kicker then is that I was talking about how there are these mutating operations and summarizing operations, but they're both kind of follow the same flow. And that's what's really nice too, I think, with using this approach is now when we take that mutating example we had before, we're still just using across 2x. We're using the same function, but now it's a mutating operation. So take a second to look at this with my last 10 seconds.
Brian, I don't think we have the time anymore because I see 2 questions coming up here. We have 3 minutes left, and I really would like to go to this question. So maybe we can skip here and just go directly to the questions.
Okay, that's fine. I want to call it that. I think it's really nice that you have this consistency between your mutating and summarizing pairwise operations in this, or again, just there's a bunch of other functions in this package I think are really great and worth looking at too. So here are links to.
It's fascinating to that you showed how the Tidyverse and Tidy models work in combination. I'm always amazed about it, all the new tools, and it gets easier and easier. I think that is what you also demonstrated with your talk. I just want to go to Robert, who asked, in the correlation matrix on the diagonal, there were NAs rather than ones. Can you say what is the background for that?
I think that might just be like the default in core. I also noticed that because those would be ones, right? So it might have been some option that I had set in running the example. I should check that though. I think that may just default them out to NAs, but I'm guessing there's maybe some option you can change that. But yeah, those would obviously be ones.
And there was another question from Patrick. It just disappeared here on the question and answers. Maybe Patrick, you can ask your question just live.
It was just still there because I was asking whether the core map or the called pair map would work on group by, but you answered that, so it was redundant in that case, right?
So there is an example, and I have at the bottom of this post. I have a link to somebody who I set up an example where you do use cold pair map with the group by, but it's way more complicated. It's just like it's a lot tougher to follow. So it is possible, but it's just more effort. You basically have to separate them into list columns, and then you do it essentially. It doesn't look too bad, but it's definitely not I don't think it's as clean as the dply over approach.
I would agree.
Okay. Any questions, general questions that came up later to any of the talks? Just post it quickly in the question and answer. We have about half a minute left, so it should be enough for one more question. Okay. Well, then I can use the time to thank all of you. I think it was an interesting session. And I think the name Expanding the Tidyverse was really well chosen because that's what we got here. We got more insights into the Tidyverse, how you can expand it, how it works. I wish you all a good day, a good night in Dax's case. And yeah, thank you again and goodbye.